Today we're going to look at separating a mixture of a acid reactive compound, base reactive compound, and a neutral compound. And we've selected benzoic acid, p-bromoaniline, and biphenyl for our compounds. And we've weighed out 300 milligrams of a mixture of those, which is roughly equal mixture of each component. And we are going to utilize the acid and base properties along with organic and aqueous solvents to separate them. Now, traditionally, we would do this inside what is called a separatory funnel. And here's an example of that. And this allows us to have two different layers of a fluid inside of the funnel and then selectively drain one at a time, and then we could separate the two layers. We are going to be utilizing a smaller scale process in which we will use a centrifuge tube and just pipette out from the bottom and isolate the layers that way just by using a pipette instead. So we need to take the mixture that we have here and we will put it inside of the centrifuge tube. Now that we have that in there, we are then going to dissolve this mixture in 4 milliliters of dichloromethane. And then the 4 milliliters doesn't have to be exact, so we're just gonna kind of pipette that in. All right, and then we will get this all dissolved. And then we'll move on to the next step, which will be working to isolate the aniline component. All right, so we have gotten all of these compounds to dissolve, and I've prepared approximately 4 milliliters of 3 molar HCl. I'm going to add that into this mixture here, and that should protonate the p-bromoaniline, and that will cause it to preferentially be dissolved in the aqueous layer up top, and then we can separate those two, and that will start to separate that first compound. So we're going to use like a cork here at the top, and then we'll agitate it a bit. I don't want to get too much up into the cork, but we do want it to be mixed well. So I'm going to mix this well, and then we'll come back. All right, we've mixed this around a fair bit, and I'm going to pipette out the bottom layer into a flask that I've labeled number 1 on. And you should weigh this flask before we get too far. And when I was mixing this, I was trying not to let it get up into the cork. So when you're doing it with a method using a centrifuge tube, we always pipette out the bottom layer, even if we want to keep the bottom layer. So we're going to remove this lower layer, and we're going to put it into a flask named number 1. and this is the organic layer since it's on the bottom, and it's on the bottom because we use dichloromethane, which is more dense than water. Now, when I'm pipetting this out, I'm going to go ahead and get a little bit of the water layer just to make sure that I capture all of the organic out of it. So now that I have this, I'm going to take the aqueous layer that has the HCl, and it should have most of the p-bromoaniline in it. And I'm just going to pour that into a flask labeled number 2. Once I do that, I'm going to repeat the steps that I did before with some fresh 3 molar hydrochloric acid. And again, another 4 milliliters of that. So I'm going to put flask number 1 back into this centrifuge tube that we're using as our separatory funnel, and I'm going to add it in the hydrochloric acid, and I'm going to mix it just like I did before. And I'm doing this to try to make sure that we get all of the p-bromoaniline out. So that will just give it some fresh solvent, and that makes it more likely to capture it all. So we're going to cap this and mix it. Now, every so often when we're mixing it, we'll want to carefully remove the stopper. I should have mentioned that before. And that is because sometimes there can be some pressure building up in the tube, and we don't want this cork to pop out and the chemicals to get on your hand or just escape in general. So I'm going to go ahead and mix this, and I'm going to go ahead and pipette these into their respective containers. And once I've done all of that, I'll come back and tell you what the next step is. All right, so after mixing it, I have again pipetted the bottom layer back into flask number 1. And I have the aqueous layer that's on top, and I'm going to combine that with what I did in the first step into flask number 2. Once I have that all isolated, then I can place the contents of flask number 1 back into here, and we can move on to the next step. So now that I've got that back into here, so the next step is actually to isolate the p-bromoaniline that we now have in this flask, but there's a lot of acid in here as well, and the acid is keeping the aniline soluble in the water. And so if we neutralize the acid and make this solution basic, then the aniline should come back out of the solution. So to do that, we're going to use some 25% NaOH. And people ask, oh, how much of the base should I use? And I usually just tell them enough. And they kind of question, like, how much is enough? And the answer is really, it's enough to make sure that we have a basic solution. So as long as we end up with a strongly basic solution, then you've added enough of the NaOH. Another indication that we haven't added enough is that I'm not seeing any precipitate yet. So since I'm not seeing precipitate yet, I'm going to go ahead and add another little bit of the NaOH. see if that's enough. And in order to really tell if that's enough, and now this is looking like it might be enough, but we'll test the pH and we'll just make sure that this solution is now strongly basic. So, you know, like a pH of 10 or above. And we can test that using a little bit of pH paper. And I've got some here, and I'll just get a little spot there, and you can see here that that's turned a dark blue, and that indicates that this is a very basic solution, and so this is now basic enough for the aniline to come back out. At this point, we will then filter that solution through a Buchner funnel, and that will isolate that compound. And what we should do is we should label our filter paper and then go weigh this, so that then once everything is dried, we can determine how much of the aniline we've isolated. So we've placed the aniline mixture on ice, on an ice bath, to help cool it down, and that will make sure that as much as possible will come back out of the solution. And in the meantime, I've already weighed a filter paper and labeled it for aniline. So this is 0.175 grams for the filter paper, and I put an A on there to label it that I'm going to filter aniline in there. So while that's cooling down, we can move on to the next step, which is to add 2 milliliters of sodium bicarbonate 5% solution to the organic layer, the dichloromethane layer, and this should react with the benzoic acid, and it will make carbon dioxide, so we will want to vent this a bit more than the other step was. And this should deprotonate the carboxylic acid and cause it to be much more soluble in water. And then the benzoic acid will then transition into the aqueous layer, and then we will separate that from the mixture. All right, so after mixing this, we have generated some carbon dioxide gas there, and we're just going to let that sit for a minute. And in the meantime, the aniline has cooled down enough, and we're going to filter that through our Buchner funnel. I should also mention that if you're going to write on the filter paper, you need to write it in pencil, because if you write it in pen, that could contaminate things here. But the pencil won't be a problem. And there's a little bit left in there, and I'm going to use a wash bottle and kind of spray it out into the filter. Now, I'm not expecting a lot, and so you might look at that and say it doesn't look like there's much on the filter, but considering that there's theoretically about 100 milligrams of the aniline and 100 milligrams of biphenyl and 100 milligrams of the benzoic acid, I'm not expecting to see much in the filter paper. All right, so while the Buchner funnel is kind of pulling some more air through, and we're letting everything try to dry up a little bit before we move on there. In the meantime, I went ahead and pipetted the bottom layer out of the centrifuge tube and back into flask number 1, which is where we put the organic layer each time. And I have the solution of the sodium bicarbonate and what should be now deprotonated benzoic acid. I'm going to place that into a container labeled number 3 just to keep track of it. And then I'm going to repeat that last step. So I'm going to put all of the organic layer back into the centrifuge tube and add a fresh 2 milliliters of the sodium bicarbonate into our centrifuge tube and repeat this extraction again, just like we did for the aniline portion. We want to make sure that we're getting all of it. So once that's completed, I will come back and go over what's next. All right, well, the aniline has been on the vacuum for a little while, and now we're going to get the filter paper out. And I usually like to take the Buchner funnel all the way out of the filter flask and just kind of get under it that way. And that way I can set it aside. And I want to make sure that I don't have any solid material around the edges. So I will just use my spatula to check for that, because sometimes it will have a tendency to leave a little bit on there. And when we're dealing with such small amounts here, we want to make sure that we get it all. And we're also going to use this in the next step for the benzoic acid, so we do not want to contaminate the next sample with that. And you can try to accelerate the drying here with perhaps a heat lamp or something like that, but I'm going to recommend that we just put this in our locker and come back the next week and we'll weigh it then. And so that way we won't potentially melt the material that we have under the heat lamp, and sometimes that can go into the filter paper, and that just makes it hard to isolate later. So we'll do that, and then we will collect all of the data the next week. So back to our centrifuge tube, our separatory funnel. I've mixed this around and I had to vent the cap a few times, especially in this step, because it does evolve carbon dioxide gas. And at this point, I need to pipette the bottom layer back into flask number 1, and then I will combine the top layer into flask number 3. And once I've done that, I will come back and show you the next step, which is how to isolate the benzoic acid. So now we have pipetted the bottom layer back into flask number 1. We've combined the top layer into flask number 3. This is where our benzoic acid should be. And just to make sure that we do not have residual water left with the organic layer, I'm going to use some anhydrous sodium sulfate, and I'll just add a little bit into our dichloromethane flask. So just in case there's some water that was left in here, this will help pull that back out. Maybe I need a little more. I don't want to add too much, but I do want to get all the water out. So I'll just set that aside while I'm working on the next part, which will be to precipitate out the benzoic acid. So now, to get the benzoic acid out, we need to acidify what's left in here. And I have a bottle of 6 molar hydrochloric acid. And again, I'm going to add enough hydrochloric acid to make sure that this is acidic. So I'll just put a couple shots of this stuff in here. That'll probably do it, but I will check the pH paper to verify that. And you can also see how a lot of solid came out, and the benzoic acid tends to be pretty fluffy, and I think it looks pretty cool when it comes out of the solution like that. It's probably the best part about this whole lab, is that one step right there. So I'll just grab a little of this, test the pH paper, and it's showing red, and that means it's acidic, at least for this pH paper. And so I think we've added enough acid. So at this point, we will need another filter paper that is weighed and then labeled for the benzoic acid. So I'm going to go ahead and weigh this and get that all set up. All right, well, while I was weighing the filter paper, we did place the beaker that contains the benzoic acid in the ice bath just to further help reduce the solubility. And now I have prepared the filter paper, which I labeled as BZ for benzoic acid. And then I'm going to get all of this out of the beaker and into the funnel. All right, so I have poured the benzoic acid into the filter, and I'm letting that run a little bit to help dry the filter paper up a little bit. But in the meantime, we have the dichloromethane solution here that should contain the biphenyl inside, and there's also drying agent in there. But with an Erlenmeyer funnel or flask, it's purposely made for decanting so that you can pour off fluids without letting the solid go. That's one of the reasons why it's shaped like that. And you can see there how I was able to pour it in, and I just being careful without allowing the drying agent to go into the other flask or beaker. Then to isolate the biphenyl, it's just dissolved in here, and so what we're going to do is come over to the fume hood, and we're going to use a compressed air line to help blow this down. So get the fume hood on, and then we just want a little bit of compressed air coming out of here, and that will help speed up the evaporation. And this will take a few minutes, so we've just set up a way to have a clamp kind of hold this rubber hose that's coming out of the compressed air line, so I don't have to sit here and hold it the whole time, and that will just help the dichloromethane come out. I like using beakers in this case because it evaporates faster out of a beaker. If you use an Erlenmeyer flask, it's usually a little bit slower. Also, the beaker will be easier to get the final material out of just because it has a bigger opening, and I can get my spatula in there and scrape it out a lot faster. So we'll just let that sit there. It's a pretty small amount of fluid. Dichloromethane boils temperature, so this shouldn't take too long. And while we're working on that, we can always do some cleanup or work with our other material. So while we're waiting for the dichloromethane to evaporate, I've placed the aniline filter paper and the benzoic acid filter paper in the lower cabinet of our lockers here, and we're going to let this dry over the week, and then the next week we will determine how much that we have and complete the experiment on that front. Once it's dry in the fume hood, I will bring you back and show you what to do in that case. Alright, well, this is the result of evaporating all of the dichloromethane solvent, and as you can see, we have some solid residue left on the bottom, which we will then scrape out with a spatula and isolate that way and weigh it. We're going to keep all of these until the next week, one, so that the other water-based ones can dry, which takes longer than when there's an organic solvent to evaporate, and two, we'll get some IRs of these and show prove their identity. So with that, hope you enjoyed this video on how to do a microscale extraction, and we'll see you in the next one.